Hi everyone. So in the next episode of our MIPS video series on physical AI, I'm going to be talking to Derry Murphy, and we're going to be discussing about the communication side of physical AI. So Derry, nice to meet you.
Yeah, nice to meet you, Mike. Thanks for having me.
So to start with, when MIPS says about communicating physical AI, what does that mean basically?
Yes, that's a great place to start. We have a big focus here in MIPS on physical AI, and we like to break down the application into four components. There's the sense, the think, the act, and the communicate. And in communicate, we're focused on data orchestration and movement, so getting the data to where it needs to be in a fast and secure manner. So physical AI, they can generate large amounts of data, and this can create challenges in getting that data quickly to where they need to be to other resources for processing. And at the physical edge, then sensor and camera data needs to be delivered to accelerators, while decision data needs to be delivered back to the actuators. And then after the action, there's again new data for the accelerators. So it's a continuous process. And the i8500 handles this process very efficiently and closes the loop for the system.
So as you say, sort of this, it's data coming in, it's in this sort of continuous loop. Then it's communicating that to whatever action's being taken, and then that could be responding then to what happens because that action's been taken. So, okay, so that makes sense. You mentioned the i8 500. So, in relation to sort of edge-based physical AI, what are the values that brings to computation and the communication side of that?
Well, I think, as I mentioned, the key things are getting the data securely and efficiently reliably with low latency to where it needs to go. So that's where the i8500 really specialize. It has a lot of features that can very securely and very efficiently deliver the data.
Mhm.
Uh, but the i8500 is very flexible. So as we kind of think of physical AI, we're kind of thinking about the operations at the edge of AI. But that's oftentimes that also has to go back up through the system to the data center for bigger decisions. And actually, i8500 is very flexible, so it can be used in a smaller configuration at the edge with a couple of cores to quickly manage the data orchestration. But it
Mhm.
can also then scale up to multi-cores and multi-clusters even, and it can be used up in the data center to um, in a hugely parallel design to manage the data movement within the data center itself.
Okay, so like you say, it can be scaled up from quite simple implementations to full, sort of much larger sort of clusters and so forth. Okay, so that's interesting. Maybe let's look at the data orchestration part a little bit more then. So maybe you could give us some details of what that basically entails.
Yes, so for data orchestration, we're talking about intelligently organizing data and combining it. So
Mhm.
coordinating where the data needs to be, and then sometimes even moving it directly to the think processors or accelerators for acting upon. So this could apply to physical AI at the edge, as I mentioned, in a number of cores, a number of streams, or all the way up in the data center itself, where it's managing hugely parallel amounts of data and enabling data to come efficiently to the processors. And actually, there in that application, it can also do some of the pre-processing, and in that way, it can offload the main processors to ensure that they can keep their functionality focused on doing the key AI processing itself.
Okay. And then the data management side of it then, I mean, first of all, why is that so important from an AI perspective to have strong data management?
Well, I think in AI, I mentioned earlier that the AI applications generate huge amounts of data,
Hmm.
and oft, as we also noted, that needs to be delivered to the think processors or accelerators for computation. Oftentimes in these systems, the think processor is held back by not having access to data quickly enough, or
Okay.
sometimes it does have to pre-process data as well. So that's where in a management function, the MIPS i8500 can offload that functionality from the main core processor, can ensure the data is delivered efficiently and securely on time, and it can also offload some of that pre-processing. So at the main processing engine can function as efficiently as possible.
So as you say, then you don't want the think part of that to be held up. They don't want a backlog to be caused because it can't get hold of the data in a timely
Correct.
manner, and that's then going to make the whole thing less efficient, basically, almost.
Exactly. And then when it gets the data, you want it to be doing its computations and not doing formatting or pre-processing or encryption. That's other stuff that i8500 can handle very effectively.
Okay, so it's making sure there's enough bandwidth available for the think processor to be able to start the computations that it needs to do, and then the act process then
Right.
is happens in a you know in a timely manner, so that keeps in, and especially obviously in mission critical type applications or things where there's functional safety aspects to it. I guess if the think processor is being held back, then you're at risk of there being safety issues or some other problem that could have serious cost to it. Yeah. Okay.
Yeah, that's right. At real-time applications, then it's very important that the data is moved through really quickly because we cannot afford long latencies. So that's where i8500 ensures that data is delivered on time and decisions are delivered on time so that the operation can happen when it's supposed to happen.
So, what specifically would you say in terms of the i8500? Why is it particularly suitable for from the orchestration and the data management point of view? What's the things that make it stand out in comparison to other options?
The i8500 has actually been designed from the ground up for this kind of functionality, so it's really well suited for data orchestration and management. So some of the key things attributes include its low latency.
Yeah.
That's very key, and then it can also be closely coupled with functional accelerators to perform the think processing, and also it also has bulk data movement capabilities. So across the different parts of the system, it can be used for data management very effectively.
Okay, so that's cool. What are the other attributes, other capabilities that it's got as a core that are worth mentioning?
The MIPS i8500 it's a pretty compact design. It's a 9-stage in-order processor, so it provides a nice balance between performance and complexity. It's then very area efficient and provides very low latency for these kind of real-time applications. It's also the first RISC-V processor to include four-way simultaneous multi-threading, and so
Hmm.
that's a real help in throughput while managing the area. Uh, it's also supports a bunch of different memory topologies, which can help as we scale up or scale down. And then for very efficient low latency, it also has scratchpad RAMs, so we can use those to provide very low latency and deterministic accesses to the memory.
Okay, and again, that'll be important in a safety critical type context because
Yes,
you want to have that. Yeah,
hugely important. So they're, security, low latency, determinism are
yeah.
all very critical features.
Okay, is that similar to a four core design?
No, this is different. So a four-core
Okay.
design will have four complete cores connected together in a cluster. So simultaneous multi-threading allows us to get a lot of that functionality without having the full four cores. So we just replicate some of the registers and we add some arbitration logic. So that allows for threads to run in parallel. So the idea then is that we can utilize the single core we have and get, but we can get a lot more performance than a single core because we're filling up those waiting stages with processing, but we don't need to have all of the area impact that you would with 4 cores. And
Okay, so this is a
in
more
reality,
streamlined equivalent. It gets
yeah,
similar results, but without having to have the full blown four core.
yes, because in reality, then most processors will be waiting or they will have cache misses and they won't be doing work for some of the time. So we're efficiently making use of that.
Yeah, and
Now
then
that
that's
said, of course, we can also have 4 cores of MIPS i8500 or up to 6 in a cluster, and each of those can still have 4 threads. So we can get a huge amount of throughput very efficiently and effectively in a lesser area.
okay. But as you say, then you're taking up less area, it's less complicated, but it's still getting the benefits, should we say, without having to invest in extra real estate in the chip, I guess.
Exactly, and our customers care about cost, of course, but there's also thermal aspects, so you're
Sure.
minimizing the area and bringing down, and that's really critical for something like a data center, for example,
Yeah.
where heat is becoming a really big issue.
And
And
then you mentioned the simultaneous multi-thread. So obviously you might have all these different tasks going on at once, and some of them might be control loop type things. And so actually having, sort of the ability to do multi-threading operations, I guess that's really vital in a lot of the use cases we're talking about here. Yeah.
yeah, that's very key for the efficiency that we are providing. So, uh, simultaneous multi-threading is a hardware feature which allows multiple instructions from multiple software threads to be processed in parallel. And so this can provide a really great boost in performance, throughput, and IPC by
Mhm.
keeping the core busy. For example, if one thread is stalled or waiting for data, then one of the other threads can proceed. And in fact, the i8500 can issue up to 3 instructions into execution every clock cycle, and it can support up to 4 hardware threads or hearts, as they're called in our architecture,
Mhm.
and can switch between these very efficiently, and enabling it to process uh, up instructions from up to 4 threads in parallel.
Okay. But this can keep the throughput high and basically stop there being any sort of holdups because of, data sort of being,
Exactly. I
yeah.
think, the thing you really want is to keep the processor active. And
Mm.
so to get the most efficiency, we don't want it to be stalled waiting for data,
Yeah.
or waiting for something to complete. So we can run some instructions from another thread and keep the processor busy. In this way, we can get the maximum utilization out of the core without having to increase the area very much.
Okay. So that's cool. And coming back to what you said earlier as well as the scalability. So obviously you could sort of start off with quite a small installation for something that's just got to do a very basic sort of keyword spotting or something like that, and then you've got other ones that can go completely. So are you seeing clients who want to start off with sort of more simple sort of implementations, but then their second generation they're going to say, okay, well, we need to add more functionality to that? And is that sort of important that you've got like a, a sort of basically a path for them to ramp up the functionality if they need to?
I think it's probably more applicable to the application and where it's being used
Yeah.
and how it's being used. So as we kind of mentioned, being at the physical edge, and maybe we're uh, orchestrating and managing a bunch of control data for a bunch of control motors, we might just need, a couple of cores down there. But if we kind of go up into data management and movement in the data center, then we might build that into multiple clusters. So each of the
Yeah.
clusters could have a bunch of cores. Each of those cores could be up to 4-way multi-threaded. And then the ID500 comes with a coherence manager that provides coherent L2 and also manages coherence across all the clusters.
So how does the i8 500 sort of manage to get such low latency levels?
Well, first off, there's our compact pipeline
Yeah.
and the zero overhead context switching between the threads, and also the low latency I/O port in the coherency manager.
Hmm.
But really, the real magic happens when customers take advantage of the optional scratchpad RAMs.
Right.
So the i8500 allows up to 1 megabyte of instruction and data scratchpad RAMs separate from the cache systems. And the scratchpad RAM can be accessed as fast as the L1 cache in only 3 cycles, but the data can be provided much faster to the accelerator than through a cache system with no CPU overhead. So that provides the performance that's really needed for a real-time system. Very good throughput, very low latency, which is very, and secure, which is really important. Coherent interconnect.
So that effectively controls all of the different clusters in a. Okay.
That keeps them all coherent. So that's kind of very
Right.
important. And then kind of back to your earlier question. So if we're in a storage or data center type of application, so we can have many clusters, and each of those clusters can have up to 8 accelerators as well. So customers may find that they want to offload more functionality to the MIPS i8500 subsystem, and then they could grow the number of clusters in a future design to help offload more the main processors.
Okay, but there is the scope then for them to ramp it up as and when they need it. Okay, which is good.
Absolutely, we can scale up to 64 clusters, each having up to 6 cores or up to 8 accelerators, and so we can go up to 1,536 data streams if you consider the 4 hardware threads per each core. So it's
Okay, so that's
pretty.
a lot of data threads that it can deal with simultaneously. Okay, so that can all
That's a lot.
be right. So that again, it gives you a lot of scope to handle a lot of different data inputs there and so forth. Okay, so that's good.
Exactly, and I think we spoke at the start about the flexibility of how the i8500 can scale up and scale down. So, the example at the very physical edge, or something in between, all the way up to the data center. So, from a couple of cores to multiple clusters.
Just going back to the coherence manager part of that. So that's really important then in keeping the latency low, allowing you to have deterministic operation. Would that be right?
Well, the coherence manager has a couple of functions. So it provides the shared level 2 cache for the cores in the cluster, and
Yeah.
then it also provides low latency I/O for
Yeah.
the accelerators, and then it also keeps all the cores in the cluster and all the clusters in the design coherent across the coherent interconnect bus.
So are there any elements of MIPS proprietary designs used in the i8 500?
Well, the i8500 is fully RISC-V compatible and compliant with the RVB23 standard profile. Having said that, we have to remember that MIPS has over 40 years of expertise as a leading CPU provider servicing these markets. So of course we leverage this expertise to build our products on this great foundation. For example, the RISC-V architecture was defined around the concept of a heart, a hardware thread, and
Yeah.
the i8500 is the first RISC-V processor to support simultaneous multi-threading. That's a feature which has long been the hallmark of MIPS CPUs and aligns with the concepts of multiple hearts in one CPU core. And many of our customers already use this in prior MIPS designs in their products. Also, the i8500 employs several MIPS defined instructions. So RISC-V allows for custom instructions. There are some that we develop, which we call MIPS defined instructions or MDIs, and they can help to improve the performance and efficiency, especially in data management. Examples of this are the wide data store and load operations, and global TLB and cache management instructions.
Maybe just coming back to the sort of applications then that the i8500 is sort of suitable for, what would be good examples of where it would be used?
There's quite a lot of applications where it's suitable because of its scalability. So we mentioned the physical edge, and I think I gave an example of
Yeah.
coordinating motor control there. In automotive, several of the predecessors to MIPS i8500 are used in the Mobileye IQ5 and IQ6 processor. So that's a good physical AI application. Uh, Also, then it can be used in the data center or storage in a highly parallel design, as we mentioned, for the data management. It's very suitable also for networking. So that's kind of an area where you often get a lot of cache misses, for example, and so you have threads which are stalled. So the multi-threaded design is really efficient there in creating high throughput in a very efficient design. It can also be used in communications itself, so for 5G and 6G architecture, both on the optical networks or on the radio networks. So there's a lot of pre-processing, there's a lot of data management that in a similar way, like we talked about in the data center of coordinating and offloading some functions, it can do a lot of that functionality in the communications infrastructure application as well. Yeah, I guess the other thing to mention is that the MIPS i8500 is a full application processor, so it can also be used, as a full application processor in embedded designs, and very efficient for that. Um, it runs Linux and or real-time OS, and also, we have support for big Indian and little Indian configurations, which is also very useful for some networking applications.
Okay. So anything basically though where there's either sensor fusion involved, somewhere there's lots of different sources, anything where there's control loops and so forth, and so as you mentioned, industrial networking and stuff like that could be potentially, and then right up to sort of big clusters for data centers and all that. So it's a pretty versatile platform in that respect. Then
Yes, it's very scalable, very versatile, but at the same time, it's not going to be the big compute engine in the design.
no,
It can be, in a very less complex design. It can be the application processor, so it's fully capable of making decisions, but it knows it's designed for in the bigger designs. It's designed for the data orchestration and management. That's where it
yeah.
excels.
So it complements what's going on at the think part of what MIPS is doing and the sense part as well. It's basically sort of
Exactly.
yeah,
This is kind of I'll say the kind of the glue to management function. So it's making sure that, all the other parts of the system have the data that they need, doing that securely, doing that efficiently at low latency. So many times these are real-time applications that we need to respect that, get the data to where it needs to go in the right time, and to do that in a secure and efficient manner. So that's really where it plays in the physical AI realm.
So what's the time frame on it?
Well, we officially launched the i8500 back in October, and our lead partners are already designing with it. The full production release will be coming up in the next few months, but in the meantime, we have a fully cycle accurate model available in our MIPS Atlas Explorer simulation environment, so customers can start developing software with it right away.
So Darius, it's been a real pleasure speaking to you. Thanks for your time, and yeah, hopefully we get to speak sometime in the future.
Yes, thanks, Mike. Really good to have the conversation and to discuss more about our I-8500.